Welcome to my Complete CCNA Cisco Certified Network Associate course. This is Jeremy's IT Lab. Since this is the first video, allow me to introduce the course. This course aims to be a complete course for the CCNA, including everything you need to pass the exam, all 100% free. There will be lecture videos covering every topic on Cisco's official exam topics list, practice quizzes covering the material in each lecture, flashcards to help you review and remember what you learned, practice labs using Cisco's network simulation software packet tracer, and at the end, multiple practice exams to get you ready for the real thing. Although this course will be based on Cisco's official exam topics list, I also want to give you extra information to improve your understanding of networks in general. That additional context should also help you understand the exam topics. Because this is the first video in this series, I want to talk about who this course is for. This course is for anyone who wants to pass the CCNA 200 to 301 exam. At the time of recording this video, this is a new exam that isn't released yet, but will be coming on February 24th, 2020. Although a lot of the information will overlap with the old CCNA, the course will be based on the exam topics for the 200 to 301 exam. This course is for anyone who wants to learn about computer networking. You don't necessarily have to take the CCNA 200 to 301 exam. This course will cover lots of valuable information regarding computer networking, even if you're not aiming for the CCNA. The only requirement for this course is that you have a basic familiarity with computers. I will cover all the foundational networking knowledge at the beginning of the course, so you don't need any prior knowledge of networking. And you also don't need to know programming or anything like that to start this course. With no further ado, let's get started. Our first lesson will cover network devices. This knowledge will be the foundation which we will build upon during the rest of this course. Take a look at this sample network here. Do you know what each of these symbols represents and their function in a network? At the end of this lesson, you'll know these and more and how they work together to make a network. We won't go into too many details in this lesson. There's plenty of time to dig deeper in future lessons. But these first few videos are meant to give you the foundational knowledge which we will build upon in future lessons. So, what is a network? Let's ask our friends at Wikipedia. A computer network is a digital communications network which allows nodes to share resources. Well, if you didn't understand before, you probably still don't after reading just that. Let's look further. The definition states that a network allows nodes to share resources. What is a node? I'll introduce some types of network nodes here, some of which appeared in the sample network on the previous slide. This is a router. You probably heard a word before and have a general idea what a router is, but I'll explain a router's function in this lesson. Next, this is a switch. Maybe you're familiar with what a switch is, maybe not. It serves a different function than a router, but is also similar in many ways. This next one is a firewall. You're probably familiar with firewalls, and you most likely have a firewall installed on your computer. That's a software firewall. But large networks usually have a hardware firewall, a separate network appliance, which helps protect the network. This next symbol represents a server. If you know computers, you surely have heard of servers before. What exactly do they do? Well, if you're watching this video, you're getting it from a server on the internet. The last symbol on this slide is a client. You're using a client to watch this video, whether it's a smartphone, a laptop, a desktop PC, or whatever. What exactly is a client? Let's get into it. Over the next few slides, let's build a sample network and look at the functions of each of these network nodes in the network. You might also hear clients, as well as the previous node type servers, referred to as end-hosts or endpoints. Okay, so we looked at some types of network nodes, but we didn't really examine exactly what each type of node does in a network. Let's build a network and examine each node's role. So, here we have two PCs, PC1 on the left and PC2 on the right. This is a network. However, if I connect them together with a cable, we now have a network. That's right, two PCs connected together actually makes a network. Now, it's a very simple network. But if we take a look at that Wikipedia definition once more, a computer network is a digital telecommunications network which allows nodes to share resources. Now that these two nodes are connected, they can share resources and essentially have a conversation with each other. Now, I'm representing clients with this symbol, but there are all kinds of devices which can be network clients. For example, a laptop, a desktop PC running Microsoft Windows, an iMac running Mac OS, an Apple iPhone running iOS. These are just a few examples of devices which can be network clients. So, let's give a simple definition of a client. A client is a device that accesses a service made available by a server. Okay, since server is part of the definition of a client, to understand one, you have to understand the other. So, what's a server? Let's take a look. I use this symbol to represent a server. When you think of the word server, you may think of something like this IBM server or this Dell server. And indeed, these are powerful servers, and you'll see rows and rows of servers like these in data centers. However, not all servers look like this. In fact, any of the clients we looked at in the previous slide can be servers too. How is that possible? Well, let's look at the definition of a client again, and then compare it to the definition of a server. The definition we used for a client was, a client is a device that accesses a service made available by a server. So, we can basically reverse that definition to know what a server is. A server is a device that provides functions or services for clients. So, let's look at the simple network of two PCs connected with a cable that we saw before. Remember this network? Watch this little exchange between the two PCs, and think which of them is a server and which is a client. PC1 asks PC2 for file image.jpg. PC2 responds and sends a requested image file. So, which is a client and which is a server? Well, PC1 is the one requesting the service, requesting for the image to be sent. And PC2 is the one providing the service, the one sending the image. So that makes PC1 the client and PC2 the server. Let's look at another example of a client-server relationship. On the left is your computer, or perhaps your smartphone, whatever you're using to watch this video. On the right is a YouTube server, which contains this video. What do you think the blue cloud in the middle represents? The answer is the internet. In network diagrams, a cloud is often used to represent the internet, or in any situation where the details of that part of the network aren't necessary. The internet is a very complex network, and for the sake of this diagram, all we need to know is that data from your computer passes through the internet to reach the YouTube server. The exact details of the internet aren't important for this diagram, so we can simply use this cloud to represent the internet. So, your computer sends a request to the YouTube server for this YouTube page, including the video. And YouTube server sends the data, passing to the internet, back to your PC. However, YouTube doesn't send the data all at once. It sends you a stream of data until you've watched the whole video. For one more example, let's say you want to get a video from your friend. You both have iPhones, so you ask him to send you the video by AirDrop. Your phone requests the video, and his phone responds, sending the video. You probably know it by now, but which phone is the client and which is the server? As you probably guessed, your phone on the left is a client, and your friend's phone on the right is a server. To review once more, a client is a device that accesses a service made available by a server, and a server is a device that provides functions or services for clients. Also keep in mind, the same device can be a client in some situations and a server in other situations. Okay, hopefully you have a better idea what a client is and what a server is. Now, let's build out the network further and show the next part of the connection between end hosts and the internet. Let's say this is a network for an enterprise, and this enterprise has a branch in New York and a branch in Tokyo. Of course, a real enterprise branch will have more than just a couple PCs or a couple servers, but I also couldn't fit an entire network on this one slide. Now, typically, you don't connect end hosts like PCs or servers directly to each other. You aggregate the connections to a device called a switch. As you can see, the two PCs are connected to switch 1, and the two servers are connected to switch 2. Switches have lots of interfaces for you to connect end hosts to. Look at this Cisco Catalyst switch. As you can see, lots of interfaces or ports to plug your PCs or servers into. Switches are used to forward traffic within a LAN, a local area network, PC1 and PC2, as well as other devices plugged into switch 1, such as a network printer or another PC, all reside on the same local area network. The same goes for any devices connected to switch 2 in the Tokyo branch. So we have one LAN on the left and one LAN on the right. The hosts within each LAN can send data to each other, for example, PC1 to PC2. However, these switches cannot connect directly to the internet and send data between the two LANs. So let's talk more about switches. Here on the left is the same Cisco switch from the last slide. It's a Catalyst 9200 model switch. On the right is a Catalyst 3650 model switch. Catalyst switches are Cisco's enterprise-grade switches, used by many enterprises to connect their LANs.